Good day, girls. Today we will be doing Mathematics Part 2, that is Geometry, the first chapter, Similarity, the second part of the chapter. We've already finished with the first part and completed exercise 1.1. I hope you have solved it into your notebook. We go to the second part. We begin with the theorem, Basic Proportionality Theorem, also known as BPT. The statement of this theorem: if a line parallel to the side of a triangle intersects the remaining side in two distinct points, then the line divides the side in the same proportion. Given triangle ABC, in triangle ABC, we have line L is parallel to one side of the triangle. Now, a triangle has got three sides: AB, AC and BC. Line L is parallel to one of the side BC. Now it has got remaining two sides. AB and AC are the remaining two sides. Now if a line is parallel to one of the side, then the statement says then the line divides the side in the remaining proportion. That is, this line L divides the remaining two sides AB and AC at point P and Q. Then we can prove that AP upon PB is equal to AQ upon QC. In short, in BPT theorem, what is given is this one line L is parallel to BC. Then we can say AP upon PB is equal to AQ upon QC. Now, to begin with the proof, there is a small construction. You need to join PC and you have to join QB. By drawing these two lines, you get many small triangles. Now, to begin with, first we take triangle APQ and QPB. APQ and PQB. Now, these two triangles, if you see these two triangles, the base of these two triangles, that is AP and BP, they lie on the same base. The base is not common, but they lie on the same line. And the vertex Q of APQ and the vertex Q of BPQ is the same point. So we say that they have a common height. As learned before 1.1, I said A1 upon A2 is equal to B1 upon B2 if they have a common height. So we are using the same concept over here, and we are saying ratio of area of triangle APQ upon area of triangle PQB is equal to AP upon PB. We can say the reason: areas proportional to base. In the same way, we take the next pair of triangle AQP and PQC over here. APQ and PQC. Now here also these two triangles, the base lies on the common line and they have a vertex P over here. So here also we can say that these two triangles have a common height. So the ratio of areas of these two triangles is equal to their corresponding base, that is AQ upon QC. The reason: areas proportional to the base. Now let us take the next two pair of triangle, that is triangle PQB, PQB and PQC. Now if you look at these two triangles, you can say PQ is a common base. And another thing about these two pairs is they lie between the two parallel lines. Therefore, in this two pair of triangle, they have a common base as well as a common height. So this is like A1 upon A2 is equal to 1, or we can say A1 is equal to A2. So we have PQ is a common base and they lie between the parallel line, and therefore they have a common height. So we can say that area of triangle PQB is equal to PQC. Now let us look at equation 1 and 2 again over here. If you look at the left side of the equation, here you have area of triangle APQ, and here in equation 2 area of triangle APQ. So both are same. Now if you look at the denominator of the first equation on the left hand side, you have triangle PQB and here you have PQC. They are two different, but here we are already saying that PQB and PQC are equal. PQB and PQC are already equal. So when in these two equations, when the left hand side are equal, we can say that the right hand side are also equal. And therefore we can say that AP upon PB is equal to AQ upon QC. That is what we have proved. So given this theorem, you need to learn that if the lines are parallel, line L is parallel to BC of a given triangle, then AP upon PB is equal to AQ upon QC. This theorem is known as the BPT theorem. Now what would its converse be? Its converse would be that this part will come under given if AP upon PB is equal to AQ upon QC, then we can say line L is parallel to BC. Okay, so that is its converse. Now we go to the next one. Next, property of an angle bisector of a triangle. The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Let me explain it to you. Now suppose consider a triangle. We have triangle A, C and B. We have a bisector CE. Since CE is the bisector, these two angles are congruent. Now in triangle ACB, if CE is the bisector, then I can say that AC upon CB is equal to AE upon EB. So it is a simple concept. You have a triangle ACB where you have a bisector CE, then you can say that AC upon CB is equal to AE upon EB. You need to learn this by heart to solve simple sums, which we will be doing it in exercise 1.2. Now we need to prove what we are saying. Let us prove this now. Property. Okay. So here we have the diagram. Over here we have to prove that AE upon EB is equal to AC upon CB. Or you can also say that AC upon CB is equal to AE upon EB. Now we have a construction over here. We have CE as the bisector of the triangle ACB. Now let us draw another line BD parallel to CE. So this bisector CE is parallel to BD. Okay, so draw a line parallel to rays CE passing through the point B and extend AC so as to intersect at point D. So we have a sum over here. This is the construction. Now, since we are already saying that CE is parallel to DB and AD as the transversal, then we can say that angle ACE is congruent to angle CBD. The reason would be they are alternate angle, they are corresponding angles. Now let us take again CE parallel to DB, and this time we will take CB as the transversal. Then you can say that angle angle ECB is congruent to angle CBD, and we can say that they are alternate angles. Now in triangle ACB, we have already said that CE is the angle bisector. So we can say that angle ACE is congruent to angle ECB. Okay. Now I hope things are looking little simple for you. Now let us look at the triangle again. We have three pairs of congruent angles. The one that is marked in blue are corresponding angles, where we have taken CE parallel to DB and AC as the transversal. So we have angle ACE congruent to angle CDB corresponding angle. Then for the same parallel line, we have taken CB as the transversal and we have marked the alternate angles ECB and CBD, which I have marked in pink. Then in triangle ACB, we have CE as the bisector, and we have marked the congruent angle with green. Now if you look carefully, you have ACE and ECB marked with blue and pink, and again they are marked with green. With this you can come to know that angle marked with blue and pink are congruent to each other. In that case, if you look at angle CBD, we can say that angle CDB is congruent to angle CBD. I hope you can understand. We have a pair of corresponding angles, we have a pair of alternate angles, and we have a pair of angles because of the bisector. When you look at all these three, we can conclude that angle CDB is congruent to angle CBD. Okay, so now what can you generalize from here? Now in triangle CDB, because D is congruent to B, we can say side CD is congruent to side CB. We can say side opposite alternate, side opposite congruent angles are congruent. Okay. Now let us come over here. What we have just said, let us go through. We have said that CE parallel to BD and AD is a transversal. Therefore, ACE is congruent to CBD corresponding angles. We have already done that. Then we did that ECB is congruent to CBE alternate angles, which I had showed you. That angle ACE is congruent to CECB given, that is because CE is the angle bisector. From all these three, we concluded that the triangles CDB is congruent to CBD. Therefore, we can say that CB is congruent to CD. CB is congruent to CD. That was till here it was explained. Okay, now let us go further. Now, let us take the whole triangle ABED. So, let us take the whole triangle in which we are saying CE is parallel to DC. What does this remind you about BPT? In a triangle, when you have a line parallel to the third side, immediately BPT should come in your mind. So, according to BPT over here, we can say that AE upon EB, that is AE upon EB is equal to AC upon CD. I repeat once again, in triangle ABD, DB parallel to CE. So, by BPT we have AE upon EB is equal to AC upon CD. But we saw that CD is congruent to CB. So, now we are going to say this again, AE upon EB is equal to AC upon CB. We are replacing AD by CB, and so we have proved this. AE upon CB is equal to CA upon CB. So this proves the property of angle bisector of a triangle. We go to the next part, that is the converse. Again, in any triangle ABC, point D lies on BC such that AB upon AC is equal to BD upon DC. Then the ray AD bisects BAC. This is the converse of the angle bisector theorem. Now we go to the next property. The next theorem, the ratio of intercept made by a transversal by three parallel lines is equal to the ratio of the corresponding intercept made on any other transversal by the same parallel line. You must have learnt this in the lower class, that if three lines are parallel to one another, line L, MN, and you have two transversal, then you have AB upon BC is equal to PQ upon QR. Now here we are going to prove this. Okay. So here what is given, we have written line L is parallel to M, parallel to N, and you have T1 and T2 as the true transversal. This is given. What we have to prove is AB upon BC is equal to PQ upon QR. You have a small construction over here, draw PC, which intersects the line M at D. Okay. Now by drawing this small construction, you can see there is a triangle be formed. APC is one triangle formed and PRC is another triangle formed. Let us look at the first triangle ACP. Now in this ACP, you know that AP is parallel to BD. Therefore, by BPT theorem, AB upon BC is equal to PD upon DC. AB upon BC is equal to PD upon DC. Now let us go to this triangle now. Let us go to triangle CPR. Again here DQ is parallel to CR. Again by BPT, PQ upon QR is equal to PD upon DC. So what is we have? Now if you look at these two equation 1 and equation 2, you have PD and DC common here, PD and DC here. So we can say that AB upon BC is equal to PQ upon QR. So all these three are parallel to each other. That is AB upon BC is equal to PD upon DC is equal to PQ upon QR. So we can say over here AB upon BC is equal to PQ upon QR. So you see this BPT is used in to solve many other theorems and many other sums. So that BPT is a very important and its converse is very important. Okay. Now let's revise what we have done so far in this part 2 of similarity. First we studied the BPT. In BPT theorem we learned that in any given triangle ABC, if these two lines are parallel, then you can say AP upon BP is equal to QC upon PQ. Then the second one is we learned the converse. For the converse of the basic proportionality theorem, if we say if PS upon SQ is equal to PT upon TR, then ST is parallel to QR. Then we learned about the property of angle bisector, theorem of bisector of angle. In any triangle ABC, if BD is the bisector, then I can say that AB upon BC is equal to AD upon DC. And the last property we have done in this part is the property of three parallel lines and their transversal. If line A at B and C are parallel, that is AX is parallel to BY is parallel to CZ, and if line L and M are their transversal, then we can say that AM upon BC is equal to XY upon YZ. So we have learned these four theorems today. Keeping these things in mind, let us solve the exercise. The first exercise, the first sum of exercise 1.2. Now here a triangle is given and the length of the segments are already given. We have to identify and tell whether in this ray PM is the bisector of angle QPR. I repeat the question. There's a triangle given here. The length of the line segments are given. We have to identify in the given figure whether ray PM is the bisector of angle QPR. Now the moment we look into angle bisector, what comes into our picture is, we will remember the angle bisector property and we will start writing it like this. We will be immediately writing QP upon PR is equal to QM upon MR. We would write like this and then we would start substituting. Okay. Now children, remember we have to, in the sum we have to identify whether PM is the bisector. So we cannot write this. If you are going to write this in the beginning and substituting the value, say QP is 7, you will write 7 upon 3 and then you will write 3.5 upon 1.5 and then you will work out, then this is a big wrong. You cannot write like this because here we have to prove that PM is the bisector. We have to prove here that it is the bisector. So in the beginning only you cannot write it. So you have to take one part at a time. So first you have to take one part, that is PQ upon PR. We have to take PQ upon PR and we write the value 7 upon 3. This cannot be divided further. We leave it as it is. We take another ratio over here. That is QM upon QR, that is 3.5 upon 1.5. So they have one digit of the decimal, it cancels, it becomes 35 upon 15 and 5 7s are 5 3s are. So we work out the different ratios together and then we will say that each of them is equal to 7 upon 3, 7 upon 3. Then we say in triangle PQR, PQ upon PR is equal to QM upon QR from 1 and 2. In the beginning only, if you are going to write this, and then substitute, you will get a big, you will get a big 0. You are not supposed to do that. And then you say in the end that ray PM bisects ray QPR. We go to the next sum. Again you have triangle RPQ and we have to show or prove or find out whether PM is the bisector. So we take the left hand side, PQ upon PR. PQ upon PR is 10 upon 7. Then we take QM upon MQ, that is 6, 8 upon 6, 2 4s are 2 3s are. Now if you go to see, it is 10 upon 7 and 4 upon 3, which is not equal. So we say in triangle PQR, PQ upon PR is not equal to QM upon QR. Therefore, ray PM does not bisect PQR. So I say once again, girls, you need to write this statement only in the end. If you are going to write PQ upon PR is equal to QM upon QR and then substitute and then write, which is not correct, and you will not get any marks for this. Now in this exercise 1.2, there are 3 sums which we have already done, the first and the second. The third sum you can do it as homework. Now we go to the second sum. Observe the figure very carefully and see. Now in triangle PQR, PM is given to be 15, PQ is given to be 25, your PR is given to be 20 and NR is given to be 8. We have to find whether the line NM is parallel to side RQ. Give reason. We have to find whether NM is parallel to RQ. So when you look at this, now we have to find out whether NM is parallel to RQ. If I can prove that PN upon NR is equal to PM upon NQ, then by converse of BPT, I can say that NM is parallel to RQ. Okay. Now for that, I need to have the value of PM and MQ. But here the value of PM is given to you, but MQ is not given. What they have given is PQ. So first we have to write this. PQ is equal to PM plus MQ. That is PQ is equal to PM plus MQ. We write this equation and we substitute the values, and then we find, taking 15 on the other side, it becomes 25 minus 15, MQ is equal to 10. But remember one thing, when you are making this equation over here, PQ is equal to PM plus MQ, you need to write P dash M dash Q. Very important. This will definitely carry half mark. What does it mean? Point P, M and Q are collinear, that is they lie on one straight line. So we can either add them or subtract them. So using this way we can calculate the value of MQ. Similarly on the other side also we need to have the value of PN and NR. Now NR is given as 8 but PN is not given, but PR is given as 20. So again we are going to do the same formula. PR is equal to PN plus NR, that is P dash N dash R. That is P dash N dash R lying in a same straight line and getting the value of PN. Now we are going to write, again here we are not going to write PN upon NR is equal to PM upon PQ. We are not going to write that because we don't know whether we can apply BP2 here or no. So first we are going to find one side, that is ratio one side, that is PM upon PN. That is 15 upon 10, that is 3 upon 2. Then we take the other side, PN upon NR, substituting the values, again getting 3 upon 2. So this ratio is also 3 upon 2, the other ratio is also 3 upon 2. Therefore we can say that PM upon NQ is equal to PN upon NR. So now we say from 1 and 2, and therefore we can say that NM is parallel to QR by the converse of BPT, that is basic proportionality theorem. Now we go to the next question, the third one. In the triangle MNP, NQ is the bisector. They have given here NQ as the bisector. If MN is 5, PN is 7, MQ as 2.5, find QP. Now here in this triangle, they have already given us that NQ is the bisector. If you remember the first sum that we did today, there we had to find out whether PN is the bisector. Okay, PM is a bisector. Here it is already given to us that it is a bisector. So directly we can write this ratio. We can write in triangle MNP, NQ bisects MNP. Therefore, MN upon PN is equal to MQ upon PQ. In exercise 1.2, the first sum we could not write this. We did not write it. We found out individual. First the left hand side and then the right hand side. But here we can write it because it is already given that NQ is the angle bisector. So we have to write this. We have to substitute the values, cross multiply and get the answer. And therefore we have PQ is equal to 3.5 units. Now we go to the fourth sum. Measures of some angles in the figures are given. Prove that AP upon PB. Now look into the triangle ABC. We have AP upon PB. We have to prove is equal to AQ upon QC. So what comes in the picture is again BPT. If you can prove PQ parallel to BC, then we can say that AP upon PQ is equal to AQ upon A. So let us take these two triangle APQ and the bigger triangle ABC. In here you can say angle APQ is parallel to PBC. It is congruent because both are 60 degree. But these are corresponding angles. So we can say that line PQ is parallel to BC. So we write PQ parallel to BC corresponding angle test. So in a given triangle, if one line is parallel to one side, that means AP upon PB is equal to AQ upon QC. The sum could be asked for 2 marks in the exam. Okay, the fifth sum. In the trapezium ABCD, identify ABCD. Now you know in trapezium one side is always parallel. You have AB parallel to PQ parallel to DC. They have given the values. AP is given to be 15, PD is given to be 12, then QC is given to be 14. They are asking you to find BC. Now any idea which property you are going to use over here? Yes, property of 3 parallel lines and their transversal. Now we already know that AB is parallel to PQ is parallel to DC. Then directly you can write the property that AP upon PD is equal to BQ upon QC. So we substitute the values over here. We cross multiply. It will be 15 into 14 upon 12. Okay, and then we have BQ is equal to 7.5. We go to the next sum, the sixth sum again. Find QP. Here, find QP given from the information given in the figure. Now what is given over here? You can see this. They are not saying that NQ is a bisector, but they have marked congruent angles over here. That means MNQ is congruent to QNP. Therefore, we can say that NQ is the bisector. So, we are going to use the angle bisector property. So, whenever you start the sum, you have to mention which triangle we are talking about. So, in triangle MNP, you will say NQ bisects the angle MNP. Therefore, you write the property over here, substitute the values, cross multiply, calculate and get QP is equal to 22.4 units. So the seventh sum is also similar like the fifth sum what we did. In the figure you can see 3 parallel lines. AB parallel to DC parallel to FE. Okay, and they have given BD as 8, DF as 4, AC as 12 and CE as X. Okay, so we are going to write solution. Line AB parallel to CD parallel to EF. So you have AC upon CE is equal to BD upon DF. Substitute the values, cross multiply, calculate and you get the value of X as equal to C. Now here they are asking you find X and AE. The x we calculated as 6. Now we have to find AE. So you will write AE is equal to AC plus CE, and you have to write the reason A dash C dash E. And then you can write AE is equal to 12 plus 6. Therefore AE is equal to 80 units. The eighth question, I'm sure looking at the figure now you can understand, it is again angle bisector property. So here again it is given that MT is the bisector, the values are given. Girls, you can do the sum on your own and then verify whether you are getting the answer as 14.8 units. Then the ninth sum. Ninth is also a similar sum compared exactly the way it is given in the 8th sum, but the values look a little different. Here we have triangle ABC and we are saying BD is the bisector. The moment a triangle is given and a bisector is given, angle bisector property should come in your mind. Okay. Now here they are given the value of AB as x. They are given the value of BC as x plus 5, DC as x plus 2 and AD as x minus 3. Normally whenever they give any sum, like if you look at the previous sum, one value was not given here, LT was not given. Out of the 4 components, 3 will be given, 1 will not be given. Now in this sum, the value of all the 4 sides is given. AB is given, BC is given, DC is given and AD is given. But in everywhere there is an x over here. So we are going to solve that. Okay, so again we are going to mention which triangle, that is ABC. BD is a bisector. Every time you have to write this statement in triangle ABC, you have to mention which is the bisector and then you have to say which angle it bisects. Here it bisects angle ABC and therefore you will write AB upon BC is equal to AD upon DC. Substitute the values as given and now you have to cross multiply. So you have x into x plus 2. So x into x, x square, x into 2, 2x. Here again you have learned expansion in the lower classes. You need to revise if you have forgotten. Okay. So here you have x into x, x square. Then 5 into x, 5x. Then you have x into minus 2 is minus 2x. Then you have 5 into minus 2, you have minus 10. This expansion is taught, you all must have been taught in different way. Whichever way you are comfortable in expanding it, you can do your own method. Okay. So now we have here 5x and 2x. There are two similar terms over here. So similar terms, one is with a plus sign, one is with a minus sign. So when you have two similar terms with opposite sign, you subtract and you put the bigger number sign and therefore you have plus 3x. So now you can calculate this, okay, and then you get the value of as x is equal to 10. Okay. Now the 10th sum is given as an activity. It is all related to BPT. Okay. So you can go through your textbook and solve the sum in your textbook itself. This sum was asked in 2020 in the board exams for 3 marks. Okay. So that's a very simple sum. You can go through it. We go to the last sum of this exercise. Okay. The diagram looks a little complicated, but it is very, very simple. If you have understood the BPT and angle bisector, you will surely be able to do this sum. Okay. Let us start. Let us start with triangle ABC. This is what is given in triangle ABC. They are saying BD is the bisector. Okay. And BD, here your angle ABC. Ray BD bisects ABC and ray CE bisects ACB. And they are also saying that AB is congruent to AC. Then prove that ED is parallel to BC. Now in a triangle, if we have to prove these two sides, two line parallel, then we have to first prove that AE upon EB is equal to AD upon DC. If we can prove that, then we can say by converse ED is parallel to BC. Okay. Now let's go one at a time. Now in triangle ABC, BD is a bisector. So we use angle bisector property. AB upon BC is equal to AD upon DC. Now we go to the other side. In triangle ABC, we take now EC to be the bisector. So we say AC upon CB is equal to AE upon EB. Okay. Can you guess? We have these two over here. But now they are saying that AB is parallel to AC. Okay. Now look at equation 1 and 2. AB and AC, the numerator, denominator are equal. So we can say that the right hand side AD upon DC is equal to EB upon BC over here. So from 1, 2 and 3 we can say that AE upon EB is equal to AD upon DC. So when you have this over here, then you can say by converse of basic proportionality theorem, ED is parallel to BC. So girls, in this exercise 1.2, it's very important for you to learn the BPT theorem. You have to learn the entire theorem by heart. Then you have to learn the statement of the converse of basic proportionality theorem. Then third, what you have to learn is the property of an angle bisector of a triangle, the theorem. That is what we have done. The theorem, you have to learn the theorem by heart. And the converse, you can learn the statement. And the last one we will be learning in this is the property of three parallel line and their transversal. You can learn this theorem also by heart. There will be a theorem asked for 3 marks in the exam. Okay, so theorems are very important. And all these theorems what we have done today, you need to learn because there are many sums, 2 mark sums, 3 mark sums that could be asked in the exam. So keep revising these theorems by heart, keep learning the property by heart, and as you see 1.2 they are very simple. Keep practicing them, and the corresponding sums you can start doing it from the problem set. Okay, thank you.